Hello everyone, my name is Deyanira, and today I'm going to be presenting a poster of a nanofiber powder for reinforcement of soft hydrogels. So also a little bit of background, we all know that hydrogels have been extensively used in the last decade for different biomedical applications, including soft tissue applications, bone applications, also for wounds, among others. And it is because they provide some characteristics that mimic the extracellular matrix, which can be beneficial, for example, for attracting cells and different purposes. So the main advantages is that they have a good porosity, which may help for the diffusion of nutrients and also of oxygen. And also they are biocompatible, which is ideal, for example, for cell therapy treatments. However, they also face some limitations, and the major one is that they have reduced mechanical properties, which can decrease the structural stability of a biomaterial. Also, this can have a reduced durability, and also this limits their use in some kind of applications, for example, in bone applications. So that's why it is important to enhance the mechanical properties of soft hydrogels for expanding this kind of applications. So right now, the composite reinforcement is one of the most popular techniques that have been using for reinforcement of hydrogels because they have a high specific surface area, which can be used for this purpose. So in this category, electrospinning is a technique that basically creates an electric field that is going to help you to have ultra-fine polymeric nanofibers mats that you can then process to use them in the hydrogels. So in this work, we hypothesized that by incorporating a nanofiber powder that is going to be created by electrospinning technique and then a post-processing treatment, we will be able to incorporate it in the hydrogel matrix, and we will enhance the mechanical properties of this hydrogel, including tensile strength and compressive modulus, as well as pore pressure for some kind of applications. So for our aims and objectives, our first aim is to improve the mechanical properties of this kind of soft hydrogels through the incorporation of this nanofiber powder. And for specific objectives, we need to fabricate nanofibers using different polymers, because for these applications, we have a lot of possibilities to use for of polymers. So this is beneficial for depending on the type of application that you need your powder for. So this is going to be using the electrospinning techniques. Then we're going to optimize the post-processing methods to convert this electrospun nanofiber mat into a fine powder that we can incorporate. Then we're going to integrate the nanofiber powder into these hydrogel matrices. And finally, we're going to assess the mechanical properties of the reinforced hydrogels through rigorous testing. For the methodology, first, we need to do the nanofiber powder fabrication, which basically is going to be first having our electrospinning technique, which is going to generate this electric field that it creates these ultrafine polymeric nanofibers. Once that we have our mat that is going to be collected in this metallic drum, we need to remove it, carefully remove it, and then we need to do a hydrolysis process. This is going to be overnight, so we make sure that all the nanofibers are separated from each other. And then we're going to do a treatment of or a post-processing technique of filtering and drying process. This is going to be also for 3 to 4 hours. And then we're going to be able to obtain our nanofiber powder. Once that we have the powder, we will be able to incorporate it. It depends of what kind of hydrogel you have. For example, in this, for this work, we work with a gelma hydrogel. So we had our formulation in a liquid state, and then we had the nanofiber powder. And finally, when you cross-link using light, you can have this reinforced hydrogel. So for the assessment, we are going to start with the mechanical testing, and this is the stage we are on right now. And then we need to do the morphological analysis, and finally the biocompatibility assays to make sure that our fibers are not affecting the compatibility of the hydrogel itself. So for our results, in the first image, you can see how the nanofibers mat looked like. And in the structure, you can see a lot of fibers. They're not completely aligned. So this is something we need to still work on, but you have all the nanofibers here. And then after the post-processing technique, we have all the nanofibers separated, which we can use for reinforce these kind of hydrogels. So we can see here our Young modulus, and even if we had a lot of dispersion, even in the worst case of the hydrogel with nanofibers, it is higher than the Young modulus of the hydrogel itself. So it proved that by adding these nanofibers, we were able to increase the mechanical properties of our material. Also, for the rheology, we were able to obtain results that indicate that basically by adding this nanofiber powder, we're not changing in a really big way the rheology of our material. Then we did tensile strength test, and this is how what it looks like having the fibers. It was a ring sample, and we were able to obtain indirect pressure measurements saying that by adding 1% of fibers, it is significantly higher than the one of the control without fibers, and also with 0.5% of fibers. So for the discussion, we still need have a lot of work for optimizing the homogeneity of our material with the nanofibers. So that is something we're working on, because it's essential to have this homogeneity for biomedical applications to ensure like consistent results and also a reliable performance. Also, furthermore, for logical and biocompatibility assays are necessary to validate our safety protocols and make sure that it is not changing the biocompatibility of the hydrogel itself. Also, the incorporation of nanofibers showed that it significantly enhance the mechanical properties of the hydrogels, and it offers potential benefits for these biomedical applications. For our conclusions and future directions, this nanofiber powder was able to enhance, as I previously mentioned, the mechanical properties of these hydrogels. However, we still need more characterization and more tests to make sure that we have all the data to make sure that this is safe for using. And also as future directions, this technique has a lot of advantages, and we are thinking also that the future directions may be to involve and to integrate peptides within the nanofibers to make sure to stabilize, and we can make some type of hydrogels that right now don't have the properties and enough properties to be able to be 3D printed and make them printable. Also, to try to improve this alignment of the nanofibers is something we need to still work on. So thank you so much for your attention, and for acknowledgements, I would like to thank the support of Eden Biotech Create. And I was also supported by a MyTax Global Link Research internship and MyTax Global Link Graduate Fellowship Award. And this work was possible also because of the funding of University of Ottawa Heart Institute and the Heart and Stroke Foundation of Canada.